have the kind of typical for the air inlet on a human.
Yeah, that's kind of what I was thinking. Yeah. And so we do, there's one place that I found that could be really nice, except it's wood. So I might try your recommendation of stapling the command strips to
Yeah, just
the wood
just
beam.
put them, stick them up, and then put a couple staples in them, and then push the
Hmm.
thing onto it.
Yeah, that'd probably work just fine. So I might do that because there's a beam on my porch that like I noticed is pretty much gets sun all day long.
Yeah,
And it's a little above my head, but not like a lot. And so it might be pretty good as far as height is concerned. And so it
and
could
you've
be.
pretty much given up the display at this point.
Yeah, because I don't, like I said, the only thing I could do is put it pretty low on a window, but then I was worried about, having it too close to firewood or whatever.
The amount of
So,
information on the LCD display is minimal anyway.
mhm,
You're if you're really worried about it, then you just, I don't know, buy an iPod Touch,
mhm.
put it on power and set it to display the data page
Yeah.
with a
Yeah, so
refresh.
basically I just have this bookmarked. So if I ever want to see what the reading is. It actually crossed my mind to like, should I just unplug the display to save the power? But I think Ray mentioned the power is pretty minimal. So
Oh, the LCD display is really trivial.
yeah,
Um,
yeah.
yeah, I mean, it takes, probably maybe nanoamps, hundreds
Yep.
of nanoamps, or very few microamps. I mean, that's why LCD watches, wristwatches run for a
Hmm.
year on a coin battery.
Yeah, yeah. So it's the same deal. Yeah,
They
but
take very little current.
so far so good. Maybe the height is a little bit low. I might explore some different options, but yesterday I got a good charge, off to a pretty good start today, it looks like. So
And the solar panel that's chosen for that has a sort of a built-in diffuser surface behind
mhm,
the plastic,
mhm,
so the absolute direction is not as critical as
mm,
on very highly polished solar panels,
gotcha.
where facing perpendicular to the rays is more advantageous than you'd think, even more than just simple geometry. Like when I
Mhm,
tested the solar cast, the original design was to have it just mounted horizontal with the solar panel facing up.
yep.
And that was sort of Ray's compromise to think that, well, then you don't have to know which way is north or which way the
Mhm,
equator is if you're in the southern
yeah,
hemisphere, and it was just very easy.
just level
And
it.
then
Yeah.
I had mine mounted that way at first, and then I mounted it at a couple different angles and watched its charging patterns. And it turns out that you'd think that it'd be like, well, Pythagorean theorem of the angle of the light, right? And
Hmm.
it's not. It's worse than that.
Okay.
And I determined that for Tokyo, at least, and Los Angeles, the best angle was 45 degrees. And
Interesting.
even though we're only at 35 degrees latitude, so you'd think that the 35 would be optimum because that'd give you the average position, the average height of the sun.
Yeah.
But the sun is lower in the sky during the early parts of the day,
Hmm.
and it's lower in the sky in the winter. So you want to optimize for, say, November through January, so that it gets enough sun as the sun kind of goes by low in the sky.
Hmm.
And you don't have to worry about optimizing for summertime because the days are so much longer that it takes care of itself.
Yep. Yeah, that makes sense.
So 10 degrees below your longitude and facing generally south, although southwest is supposedly slightly better by theory these days, because most places have more instances of morning cloudiness than evening cloudiness, or than afternoon cloudiness.
Yeah.
So, and people have done the equations on stuff on, well, should you have articulated panels that track the sun like a sunflower? And it's never economically viable,
Yeah.
because the cost of the maintenance and the mechanisms for the tracking and the smarts and all that and the
Hmm.
sensors
Yep.
cost more than an extra panel.
Yeah. Yeah.
And the extra panel more than makes up for the efficiency of tracking whatever half a dozen panels you have. So
Yeah. It
that's
makes
why
sense.
all of these mega solar installations the last 10 years are all just huge arrays of panels bolted to the ground.
Hmm. Yep. In just a handful of different angles, so that
Right.
at least a handful of them are optimal at any given time. Yeah. Yeah. That makes sense.
So
Cool. So yeah, I'm plugged in
efficiency
and.
based on efficiency can be number of watts per time, but really the one that matters is number of watts per dollar, or
Yeah.
per unit money. So that's the cost of electricity. And
Yep, makes sense.
anyway,
Cool.
how are we positioned for, or what's going on with the two new units coming out, the Radnote and the Airnote radiation, which, you know, we've been kicking this little problem of the conversion factor down the road for a decade now. And just saying, well, you know, most of the database is 334 because it's a pancake sensor, and where that doesn't apply, it's close enough we can just ignore it, and we have been.
Yeah.
I think that's about to be an invalid statement. We'll no longer be able to ignore that.
Yeah. Yeah, and I don't know, like the thing that comes to my mind is, do we even have a database of something that would allow us to do, you know, geographic multipliers that make sense, right? Like, I know you've brought this up in the past, but like, depending on where you are, you'll have a different, you know, dominant isotope in the environment. Right. And if we want to account for that, then like the very first thing we're going to need is some sort of place to look up that data. So for a given geo boundary, you know, what would the dominant isotope be?
This is where plus codes or open location codes could be really handy, because you could create a table that was just 2 characters that essentially divides the planet into a couple hundred zones.
Yeah. And the open, the open location codes are just, it's just like a square grid. Yeah, okay.
It's a quadrangle, although it's not. It's only a straight sides. If you do a projection that stretches out the poles, they become quite trapezoidal with curved sides as you get further north. But yeah, see there's the chart with the first 2 letter prefixes, and you know that might be enough for things. Now to get down to Japan, you probably want the next letter down. But the fact that it gives you a rectangle.
Yeah, I was just noticing we catch like a little bit of a little bit of mainland China in there. It looks like Russia probably.
Yeah, but each of those with 1 more letter, you divide each of those into 20 pieces again.
Yep.
So even if you did a three character table, you'd want it to be extensible so you could get as small as necessary. But I think the per device conversion factor is going to be more important. Because we don't have, you know, we'd have to, if we had a database of geographically based conversion factors, we'd have to populate that. And that's easy. You just populate it with 334 at first, and only the ones that are exceptions where we have, you know, better data, like say around Rome or I don't know, everywhere except Chernobyl and Japan, then we use some other number for that. And it might be more important for the new devices that have smaller tubes. Because the difference becomes more significant. You know, it's, if you look at it as percentage, if you're the difference between 333 and 334 is only 1/3%, you know, less. But when you're looking at a device that has a response factor of 90 to 110, you know, every number in it is a percent. So
yeah, makes sense.
I don't know.
Yeah, so I mean, it's going to be a tricky problem. I think in PostGIS, we can probably come up with something where we basically do a lookup. Like the thing that comes to my mind is it'd be great if we could do the lookup at display time, because that basically enables us to change the factor over time.
Can we build it into the templates? We should. I think it should definitely be at render time, not necessarily. I mean, if you put it in the database, then you have to have a column that has both either the conversion factor or the converted number. And I've resisted putting the microsieverts in the database because that assumes we know what the conversion factor was. And people like have said that, well, we know what we converted it to. If we ever decide that the conversion factor is wrong or needs to change, we just reprocess it. But that also assumes that we remember which number was used to derive that, you know, that particular column. So I think it would be better to, if we have a column of microsieverts per hour, then it should be calculated from the CPM occasionally or whenever the number changes, not and keep track of what was converted, not convert from a pre-conversion. Otherwise, you'd have a tendency to accumulate error.
And it's that update problem that I'm concerned about, is that, you know, so far as like kind of very quick and easy access to the data, PostGIS is not great. Like it's very good at being super relational. So I could probably craft a query that like at query time does all that proper conversion. But being able to do things like show nice dashboard pages from that is probably a non-starter, because we're probably talking queries that take a couple minutes per panel at that point.
Okay, but what's the for the near future, for the I think in the next 12 months or so at least, the base map, the radiation map, can continue to only display data from BGeiges. So that means it can use the same conversion factor and nothing really changes in regards to that.
Yep.
For the new fixed sensors, the ones that are looking, the air sensors and the new radiation sensors that'll be fixed monitors, and for that matter, even the point casts and the the NGeiges, whatever, it might be possible to build it into the template for Grafana, because I mean, is there anything that says we have to have the scale on the side match the actual data?
No, I mean, so long as it's just a multiplier, it's,
right. If it's a factor, then you just grab the CPM, label it microsieverts per hour, and run the scale up the side at a factor of 334 or 100 or whatever the one for that particular device is.
Yeah.
And you can have a template that is, okay, this template is for Airnotes, radiation. This template is for point casts. This template is for solar casts, whatever is. And right now that wouldn't be a dozen different implementations. It'd only be basically 2, because you really just have to pick the one where it has a 712 tube or a 712 type area tube and a pancake tube.
Cool. Yeah, in that case, I think it'd be pretty straightforward. And in fact, I mean, the thing that would be even more attainable, like Grafana doesn't have any easy way to say like, okay, for like a given dashboard, the device class is this, so I need to render a panel this way. Like, I don't think there's any way to do that in Grafana. But what we can do that
way to pull to a different template when you click on it to get there.
Maybe, but the thing that I was going to mention is like what should be pretty achievable is on these pages where we render our own graphs. So that one's broken. Let me load up mine because I don't think that one's broken unless someone deployed something. Let's see. I know Rob has been playing around with this page lately, but I don't think he actually deployed anything yet. Where in this case where we render the panels ourselves, this is a place where it becomes really easy to say if device class equals blah, then use this multiplier. If device class equals blah, then use this multiplier. And similarly, what we could do is if we were only worried about like point in time, what we could do is have this page go look up the appropriate multiplier for the location and then just render using that multiplier. Like basically like a view layer join at that point rather than the database layer join. We might be able to get something along the lines of location specific multipliers as well there. Not at the database, but actually in the API application. And that might be a way to tackle it.
Well, that would depend on us having a list, might be a list of 2, but some kind of a list.
Well, like you said, we can basically have, I mean, since it's only going to have what, like 3 entries,
right?
It doesn't have to be a table. It can actually just be code at that point. Like we can just have like an if statement that says, if you're in this region, then use this. If you're in this region, then use this.
Or check location, open low code. If true, this number. If else, this number.
Yeah.
Okay.
Is it easy to convert from lat long to like back to an open code?
There are published algorithms for that. Going from a lat long to a code is difficult because the lat long is a point and the OLC is an area.
It'd be like it's a contained calculation.
It gives you a corner. Going the other way is easier because this open location code, you just generate there's a lat long that is either the center or one of the corners. And for long codes, ones that are like 10 digits long, it really at a human scale it becomes not a big difference, because if you're taking the area of something the size of your hand, and trying to get a lat long for it, it's all going to come out the same whether you're with any kind of reasonable resolution and accuracy.
It looks like at least the Note devices give us the open code too, so
right, and they give you the code,
that problem. So we'd only have to worry about it for things like for non-Note devices, and
it's giving us 4 characters after the plus, Wow, that's like an area the size of your hand.
Yeah, it probably bumps around a little bit. Actually, no, it's pretty stable. So,
Well, if it only checks the GPS occasionally, then the
uh,
algorithm's gonna give the same thing, and maybe it doesn't actually render it down that low. It just what are the last two characters? Are they
uh,
constant?
yeah, for all the recent data points anyway.
XH. Okay, XH.
Yeah.
Because like mine, the code I painted on the roof here, I put 4 digits after 4 characters after the plus, only because it took 2 characters to make a quadrangle about the size of the property, but I added the last two JM just to put my initials on it.
That's cute.
Yeah, and
That the
that
JM
reduces. And
in
that's how
theory
I.
is somewhere.
Yeah, it's actually kind of over the bedroom, but it's that's how I became familiar with what the size of a code at this latitude is,
Yeah, yeah.
with 4 digits after the plus, or four
Yeah,
characters after the plus.
that's pretty much my house. So.
Yeah, and I see, and it's you paste it in the 29XR 22RX8 or 2RX8.
Yep, yep, yep. I just copied the value
Okay.
straight from Grafana.
And what are you looking at? The echelon choice. Okay. Yeah, if there's a site pluscodes.com or something run by Google that'll let
Yeah,
you convert both back and forth, and if you give it a code, it'll show you the rectangle. Um,
gotcha. Cool.
I think
So
by
yeah, I think what
default,
we probably
the
could
default's
do.
like 2 characters after the plus.
So like really short term, I don't I question if we can be that flexible. Like remember, I feel like I've mentioned this every week, but like
Hmm?
like Grafana is really like built as an operations like observability tool. So it's not built to do, geo processing, like heavy geo processing stuff. But here, this is all just Ruby code. So we could very easily say, like, look at the OLC that we have in the most recent data set. And if it's a match for this, then use this factor. If it's a match for this, then use this factor. And
Hmm.
then when we send the data to the UI to render these charts, just scale the data first.
And how do
And
we
that's
how do we make that selection based on let's say one of the other things that can happen that will change that is individual unit calibration. Okay, the characterization I did for the BGEIGs led us to think that the differences from unit to unit were below the level of resolution that we cared about. If we so this unit is 334 and that unit is
they,
336 and
they
things
would
like
be
that.
consistent for like a class of device though, right? Like it mostly has to do with the physical design of the thing. Like would two
Uh,
would two rad notes vary between the two of them pretty significantly, do you think? Or
Currently, they are.
yeah, interesting. Okay.
Okay, and we're trying to remove that by the electronics design because we're not sure where it came from. Okay,
Mm,
the early BGEIGs based on the Midcom inspector were extremely consistent.
mhm,
Okay, all of the BGEIG nanos based on the iRover are
mhm,
extremely consistent and match the ones based on the inspector.
mhm.
So it really came down to the geometry of the tube, and that was so consistent that it wasn't worth even considering.
Yeah.
Okay, now that we're starting to look at other power supplies with the Safe Pulse design, and it's got a
Mm,
little bit different response. I
mhm,
was looking at the graphs from the 1965 document that Dan posted in Airnote Dev this morning, and looking
mhm,
how
mhm,
it's how the response rate is sensitive to temperature and voltage for those thin little tubes, and thinking, okay, there's a reason to get another percent here or percent there difference.
Yep.
And they seem to be much less stable, the little thin tubes, or the 712 family of tubes, than the pancake tubes. So it's possible that there could be enough variation from unit to unit to warrant having an individual calibration for them. I
Yeah.
don't think so, and that would be a huge logistical problem to try and calibrate them. But it's something we might want to consider if we can't get the electronics to be, 2% repeatable unit to unit.
Yeah. This one here.
There it is.
1965. Nice. Cool.
Yeah, he said that the 712 is based on something the one that ended in a 4, but I think it ended in a 5
Yeah.
because it has the mica window on the end.
Cool. So yeah, I mean, I think there's a lot that we could do. I think starting very simply, having a fixed multiplier, which is basically what we're doing here. Oh wait, not here. Where's the rad note one?
Well, And what are the options for, say, displaying the radiation level in other units, like REM, Rentgens,
You'd need a second panel. It's like what we do for CNF. So you can't do switchable panels, but you can do 2 panels.
And there's no way to, so yeah, okay, because the temperature is exactly the same thing. It's exact same data, same scale, but you'd want to have like on both, either on the same side CNF mixed or the other side CNF mixed. And yeah. And in the case of the difference between microsieverts and REM, it's a factor of 10.
Yeah.
Because we're going from microsieverts to Miller REM, and there's actually a difference of 100. So you're going down, 3 digits and up 2, so it winds up being difference of 10.
Yeah, so we have just like a simple multiplier per panel, or I mean, it's technically per metric on each panel if you wanted to display multiple, but I don't know if there's, it's probably not.
CNF is actually trickier because you also have an offset.
Yep. Yeah, it's just basic math. You can
at least with REM to microsieverts, the 0 coincides. It really is just a scaling factor.
But yeah, that's part of the reason why on the page that Emery cracked up, we added like this switch that lets you do it live. But I don't think there's any way to pull that off on Grafana. So it's.
Well, we could do the same thing for REM or microsievert for easily enough.
Here, yeah, exactly.
And why does it change scale when you switch that? Oh, because it's 0 to 100 and 0 to 30. Okay.
Yep. Yeah, probably just. Actually, that's a good point. The C should probably go beyond 0 because minus is pretty common. So
yeah.
But yeah, like more to the point.
Is that scale fixed or adaptive?
It's a good question. I don't know. It's a shame Emery's not around. He could probably tell you for sure.
All the Grafana pages are adaptive, and I'm waiting for the data to build up so I can actually see what the range of like barometric pressure and humidity and stuff runs.
Yep.
And even temperature goes up and down, every 24 hours. But I think once you get like 6 months of data, you're gonna be able to see the seasonal variation also.
Cool. I actually need to drop in 2 minutes for another meeting. So this has been good. I think we can do some things. I think we're probably gonna have to start spending more time developing these pages.
Rob asked
Emery did a good job.
Is where is Emery these days? Is he settled somewhere where we can
I think Rob was going to talk to June to see if June knew about what was going on. I haven't seen a response from him in quite some time, so I don't know if he's just taking a long vacation or what. But it'd be nice to have him around. But for the time being, seems like he isn't. So
I have to talk to Yamadera-san, Jun Yamadera, on other subjects. I already called him, and I'm waiting for him to call me back. I'll ask that at the same time if I get a chance.
Cool. Sounds good. All right, I gotta get going.
Okay.
And I'll post the recording for Rob to take a look at later.
Talk next week.
All right. Bye-bye.